Yeah, we're live. What's going on? It is 7:02, 7:05 now, man. It's really getting late here. So tonight we're going to talk about turbos because we haven't talked about them in a while. It's one of my favorite subjects. We're going to talk about what I call asymmetrical turbos, and that's a name that I got from the guys back in Saab when they were doing it. And what it is on a V engine, a V8 or a V6 in the case of the Saab, what they were doing was channeling all of the exhaust from one side of the motor to the turbo. The other side ran naturally aspirated. So you might be asking yourself, well, why would they do that? Why wouldn't they just run all of the exhaust to the turbo and make it much more responsive and have it make more power? Why would anybody want to do that? Well, that's what we're here to talk about. And I've actually tried this on one occasion, and unfortunately, when I tried it, I had very limited success. Not at all like the success that the guys at Saab had. But here's where we can talk about why mine possibly didn't work, and then why a production piece from Saab would work, and when you guys might want to employ this, if at all. Because and we get into the same kind of discussion and conversation with the compound stuff. Oh yeah, you need to run compound turbo so they can really jack that boost up. With the compound stuff, especially if we're talking about with an LS motor, you can make so much power with an LS. In fact, especially if you're talking about a motor from the wrecking yard, if you have a motor from the wrecking yard, you can make more power than the motor will withstand. So there's not really a reason to run a compound setup. A compound setup is much more likely. Obviously, it's very, very popular with diesel applications. But the other application where you might want to run a compound is when you are trying to run a very, very big turbo. And you can run a smaller one in conjunction with that to help spool it up. A lot of times that's done with sequential to the small turbo, get the thing spooled up so it's making better power, so then it can spool the big. Sometimes guys do that with compound turbos. With twin turbos, that's just twin turbos run in parallel. That's not a good idea. But the question is, why or when would you want to run a turbo off of one bank of the motor and just run the other one naturally aspirated? And will that even work? I mean, that's always the question. If you're boosting from one side of the motor and blowing through the motor, and then some of the exhaust is blowing out naturally aspirated, some of it's going to the turbo to feed the turbo, will that even work? Well, Saab already showed from their stuff way back in the day that an asymmetrical turbo definitely does work. And I think that for them, what they were experimenting with, if I remember the readings right when I was going through this stuff, is that you're trying to get basically better fuel economy. So if you're running half of the motor naturally aspirated, maybe you can get better fuel economy. Although the thing I don't know is the whole motor is running under boost. What you're not getting is exhaust back pressure on one side, but you still have to have the same, because all of the intake side of it, basically the whole motor is turbocharged. So you still have the same, reduced air fuel, so you're not going to get as good a mileage there. Everything's still under pressure, and all that stuff is working the same. The only thing that happens is now when the exhaust goes out, you're not channeling that extra exhaust energy to the turbo. So then why do this? Why would anybody do this? Well, there might be some instances, like for instance, if you were trying to not make a ton of power and you wanted to maybe do a towing application and you wanted to run a small turbo on it, and you didn't want to have excessive back pressure by having a small turbo on a big motor, like a big LS motor, or even we tried it on a 454 big block. And so if you ran a small turbo on it and you could just feed it with if it had enough exhaust to get to what I call the crossover point. So you need to be able to spool the turbo up to where the turbo starts making boost, and then you have more exhaust flow, and then you have more boost and more exhaust flow, and that's what I call the turnover point. So can you get that with an asymmetrical turbo like that? And what I did on the dyno is, and this is probably why it failed, is we had a big block that we had run with a single turbo setup, and we'd also run it with twins. And we decided to try it with just a single turbo. So what I did was took the exhaust manifold off of one side and just put a normal header on it and let that side run just naturally aspirated. Then we fed the exhaust to one side using a bin that I have to a single turbo. The turbo that we used, I think, if I remember correctly, I think it was a GT45. Unfortunately, we could never get that turbo at any RPM to make anything more than about 1.5 pounds or so of boost. So it just never worked for us. And we were doing it on a blow-through carbureted application. We tried swinging the timing around. We tried swinging the air fuel around. We tried doing all sorts of things, but it would just never make boost. And I think that maybe we had too big of a turbo on there to get the thing to work. And I want to revisit that. And I want to revisit it with a smaller exhaust, and because we had a fairly good size exhaust on this, and I think that if we neck that down, and we could get the turbo spinning a little bit better. But I want to retry that because I think that it'll work. I mean, we know that with the Saab stuff that it's our Saab story. We know from the Saab stuff what they did, it actually does work. And I would just like to try it on the dyno and make it work on one of these junkyard motors, because I think it's just, it's like the compound thing with the LS. It's just a cool kind of gee whiz thing more than it is something where I would actually have an application for it. I don't know what application I would ever want that to work, but it's a cool thing to kind of try on the dyno. So let me know what you guys think. Let me know if you think that you can figure out an application where you might want to try that, where an asymmetrical turbo running off just one side, might possibly be beneficial. I'd like to hear what you guys think would be potential problems with that. Maybe why our big block didn't work. Was it just a turbo sizing problem? Was there something else that we weren't considering? And like I said, we swept the things that we could sweep. We swept air fuel, and we swept timing and stuff. And we tried lots of timing and not very much timing. And we tried going both ways to see if there was something there that could help things out. And we tried starting the load at higher RPM where the motor's making more power and all of that stuff. The thing that I would like to try, and this is going to be a little bit more involved of a test, is after seeing it work as a single turbo and then not work as an asymmetrical turbo. So we cut off 4 of the exhaust ports, basically. We cut off the feed from one side of the motor going to that exhaust to spool that turbo. What I'd like to see is I'd like to start cutting off. I'd like to have all of the exhaust going to the turbo, like a typical single turbo kit. Then I'd like to stop 2 of the exhaust flows. I'd like to run 2 ports naturally aspirated and just let that vent out. And to see if we could run it on 6 of the cylinders. Then if we could do that, could we run it on 5? Could we run it on 4? And just start taking away exhaust and letting those cylinders run naturally aspirated. Is there a combination of cylinders that would make it run better? I know when Saab did it, they did it off of just one side. They didn't do, select cylinders in the firing order that I remember right. I think it was just one side, and that was probably more for packaging than anything. But it would be interesting to try that and see. And the reason that I want to try that is because I want to run, for instance, a GT45 turbo on a big block, even a junkyard big block that we know is going to have high back pressure. So what I want to see is if we feed it with 6 of the 8 cylinders, if we have exhaust flow from 6 of the 8, then will that reduce back pressure and still spool the turbo? Can we get to like a sweet spot with that small turbo size that would otherwise have lots of back pressure? And we know from the video is already up. You guys can take a look at that. We know from that it already had lots of back pressure. So what I want to find out is if we did it with 6, would that lower the back pressure and still allow us to make power? Because like right now with that big block and the GT45 size turbo, we have more than enough response rate. It's the turbo is very responsive. So what I think is we have response rate in reserve. So I think if we take away some of the exhaust flow, we're not going to hurt response rate as much as we're going to help back pressure. That's the theory. We don't know if that's actually the case until I test it, which means I'm going to have to make an exhaust system that will allow me to, eliminate some of the tubes on the manifold. And that's possible. You just have to make it so that it's unboltable, and that's certainly possible. We also have to cap the other side of it so that we have no leaks, so that all the 6 cylinders are not leaking when they're flowing everything into the turbo. And then the other 2 will just be long tubes flowing out to the exhaust. So it will be interesting. I think that would be kind of a cool test. Again, for me, more of a gee whiz test, but it will answer answer the question on what happens with response rate when we minimize some of the exhaust flow. We've had similar tests to this where basically what I did is on a single turbo, we put multiple O2 sensors, just capped them all, and then started taking them out to see how much less responsive it was. And again, we were trying to get rid of some of the response rate, and we were trying to get rid of a rising boost curve, and we were doing it the wrong way. But it does tell you, it does dramatically change the response rate of the turbo by having some of that exhaust just go out that port, go out that hole. So it's kind of cool stuff. So let me know what you guys think. Let me know what you guys think on the asymmetrical deal, and whether or not you think that what I want to know is, in what instance would you think that an asymmetrical deal would be beneficial? So we'll read some of the responses here and see what's going on. Grant's here, Tim's here, ProCharge Mopar, Ben, John, Devin, Ken, etc., etc. All the guys are here. John, Mustang, crazy. Let's see. Racing, could this be applied to a center versus outer runners on a V8 with separate plenums, like a carb intake stall runner length, but the center longer runners are the only ones gaining boost? So you won't only want to apply the boost to some of the runners? Saab is so great, they're not in the United States anymore. Wow, shots fired at Saab. There's a guy that ran 2 different turbine housings on his 350Z twin turbo. He claimed that it had better top end than the 2 small housings and better response than the 2 big ones. I don't know how you get better on both of those, but we've run 2 mismatched turbos before and they work. Let's see, you'd have to have individual cylinder tuning. So, Sid, I'm curious why you think that the individual cylinder tuning would be different when all of them are under boost. Some of them don't have the same back pressure, but do you think that that's going to affect cylinder tuning? Stormy Eastern MT, is that Montana, I'm thinking, right? Saab actually ran the system back in the day. They had a factory V6 that had the asymmetrical turbo. So if you do a search for Saab and asymmetrical turbo, their thing will come up. Nasty Chevys is saying GM ran a turbo off of one bank of an early 6.5 turbo diesel. Thoughts on the Terminator X? Hugh, if you're going to ask a question, like ask a specific one about the Terminator X. Let me know what your question is. Are you asking whether it works and whether it's a good idea or whether it's cost efficient, or be more specific? The answer is going to be the same on all of the questions now that I've said that. I don't ever run Holley Terminator X. I only run HP and Dominator when we run stuff on the engine dyno. But lots of guys use it and it seems to work. Bill, yes, we were talking about running the turbo off of one bank, and Saab did it back in the day. Taking away cylinders can be the same thing as opening the wastegate, although what you have is a different in the firing pulses, so that may affect it a little differently. Steve says, Richard, you must be bored. What makes you think that? I love talking about turbos. You need back pressure to feed the intake. Your wastegate is already bleeding off as much as you can without losing intake pressure. Too many corks in the system. Not understanding that. Yeah, Jeremy, that's right. It's a small turbo. He thinks a small turbo would probably work, and that if you have a back pressure reading, that would give us an idea on whether or not there's and there's very little back pressure on any turbo at 1 or 1.5 psi. So it's kind of hard to tell because you can't really tell what the back pressure is doing. A lot of times they don't cross till farther out in the RPM range. Very rarely do they start with the back pressure higher than the boost pressure on loading. So they can. The turbo can be that small. Wade Kingston, would choosing non-companion cylinders for the asymmetrical test create unpredictable boost? I don't know why that would. I mean, the turbo is going to be spooled up based on the exhaust flow. I want to run 2 large turbos, exhaust routed normally, and compound intakes. I don't know what compound intakes is. I like, Tim, I'm with you. I like the Saab 900s too. I think that they were cool cars. They were, you know, they were Saab-ish. they were eccentric and quirky, but that's why I like them. Banks currently building a 496 stroker, not Gale Banks. Everyone's getting all excited. Currently building a 496 stroker from a 450 Euro for the stock. Will the stock oil pan fit? Yeah, it'll bolt onto the block the same. The oil pan should fit. You do have concerns with, especially if it's an open, like a stock open pan, you're definitely going to have windage issues. Although under 6,000, it will be not as bad. The Holly, Hugh, the Holly is works very well. The thing that you have to do is tune everything, so you have to tune all the drivability and stuff. But it can do that. Lots of people running around on that. Some World War II planes ran. Fascist Pendant says that some World War II planes ran with a turbo and the turbine coupled to the crankshaft. So that would be more a supercharger then. Tim says he got worked over by a Saab 900 in a C5 coupe up to almost 140 miles an hour. That thing must have had the boost turned all the way up. Wade, I honestly don't know the answer to that. He's talking about firing order and power strokes affecting the acceleration or the spool rate of the turbo. I would like to see that. I would like to see if pairing, you know, certain cylinders and stuff has an effect there. I think if all the exhaust is fed to the turbo, I think it works. I'd like to see if something changes that. Like, it's probably more prevalent on a 4-cylinder. So I'd like to see if pairing them does anything, especially, and then if you paired them, you probably would want to pair them with like a divided housing. I'd like to see what changing that pairing does on a true divided housing to see if there's something there. BF, hi Richard, do you recommend running push rods in an LS running a sloppy stage 2 with pack 12 18 springs? I've seen lots of guys get away with the stock stuff. I like hardened push rods when you're going with more spring rate. I think it's cheap insurance, but I've seen lots of guys run stock stuff. Was there a different compression ratio per bank? Oh, for the Saab, you mean? That's a good question, Rob. I'm not sure. I'd have to go back, and I guess I should have done a little bit more history, a little bit more research before I came on. I don't think that there was, because one side of the motor isn't the only thing getting boost. It's the only thing providing exhaust. The whole motor was turbocharged. All 6 cylinders were turbocharged, not half of the motor. Just half of the exhaust was being fed to spin the turbo. So I would suspect that the compression was the same on all cylinders. Rudimer, hi Richard. Will you ever do a video on a Buick LC2, the 3.8 SFI turbo and the Buick Turbo Regals? So are you talking about the Grand National and the Turbo Regal motors? Is that what the designation was for a Grand National motor? Mind Reader, I put to you the question, same car, near same weight, like a small engine, well built, say 250 horsepower NA versus slapping a turbo on to create the same horsepower. When it comes to torque, there will be a difference. There more than likely would be a difference in the torque curve between those two. The if one is going to create 250 horsepower, it's an NA motor is likely going to do that at a higher RPM than the turbo motor will. So the turbo motor typically would have more torque. Traditionally, that's kind of what happens. The other thing is until the turbo spools up, it won't be doing well. But after it does, it should have more torque than a 250 horsepower NA motor. Matt, if you have a 454 at the machine shop, he wants to bore a stock Gen 4 70 over. That seems like a lot, but I wouldn't run a lot of boost on it if you're going to do that. Scott, best turbo for a 4.8 to achieve 450 to 550 horsepower. Are you talking about wheel horsepower or flywheel horsepower? If it's flywheel horsepower, then the GT4582 size, which are very, very cheap. The guys from Max Speeding and CX Racing and all those guys have them. Or if you want 550 at the wheel, then you need something a little bit bigger, like a GT45, or there's lots of other Borg and precision and turbonetic stuff that will do that as well. Those are all going to be more money. Choco Smith, do you run a risk of vibration with an asymmetrical turbo? I'm assuming you're asking, especially if you do it by bank. The right bank, 5-7 fire after each other, but they'll have more exhaust pressure pushing back. The two fires with no back pressure. I don't think you'll have a vibration issue there. I've never run a Grand National. I mean, we've run Grand National motors on the chassis dyno, but I've never run one on the engine dyno. They are good motors. I mean, they're Kenny Duttweiler and Kenny Bell and all the guys have already proven that you could make like 1 million horsepower with them. And they even ran those basically at Indy, although not anything near stock ones. Oh, the turbine drove the crankshaft at cruise? So they used exhaust pressure to drive the crankshaft? Josh, do you have any recommendations for my stock bottom end 302 budget build? The plan is to use the original short block with an F303 cam, blow through carburetor, home ported E7TE heads, and aluminum intake. You don't need to port the intake. Are you running boost on this? Or is it just an NA motor? If it's just an NA motor, the heads are going to be the limiting factor. And if are you running the aluminum intake that you're talking about? Is that a stock HO intake or is it a dual plane carbureted deal? I think you said it's going to be a blow through carb. So I'm assuming it's a dual plane. So the dual plane intake, the restriction there are the heads, even if they're home ported. Evan, either one of those works. If you're going to get a motor, I would always get the bigger one. If you already have a 305, you can certainly put a turbo on it. Is there excessive back pressure from twin eBay GT35s? Well, take a look at the video that I have up on the GT35s. Although I don't remember if I had exhaust back pressure in those. Now I can't remember. But I would say no at the power level that, I mean, those are two GT3582s are about 1,000 horsepower turbos for twins on a typical LS. So your back pressure is not going to be really high with those. Oh, cool. Faster Problems channel is stoked that you're going to do some Atlas testing. Yep, I was hoping to get down there, but I don't have available dyno time right now, so I have to wait. I might go down there and do some pre-gaming, try to get it all ready so we can do more testing while I'm there. Oh, Mike, yeah, I have Hugh McKinn's book, his turbo book. That's That's an OG one, just like the superpower stuff, and the, I think Gail Banks did some stuff too. Lucky Do 79 just recently found your channel after trying to do some research on future upgrades for my 5.3 liter. Well, welcome to the channel. Marcus, if you made them that different, what happens is, and we actually did this on a 4-cylinder where we were running 2 of them, and we ran 2 different size turbos, and one of them will backfeed the other one. The guys from I think the guys from Hasport might have done this, or the guys from Jackson Racing did it. They ran 2 superchargers, same thing. They had one bigger one and one smaller one, and what happened is that when the big one gets going, it just starts backfeeding the small one. So you might have the same problem with the 2 dramatically differently sized turbos. Lucy Smith, hey Richard, I graduated a week ago with an engineering degree. Congratulations. That's no easy task. Do you have an advice on getting a job in the industry? In this industry, you want a job? So you don't want to make any money? You need to figure out what things that you want to do, what things you want to specialize in. Talk to the guys at Texas Speed, talk to the guys at Brian Tooley Racing. Find a good place and get in the door. No, please no. 5.3 engine, BTR stage 2 cam, 373 gears, 3,500 pound truck. Any suggestions on what stall converter? Is it a stage 2 truck cam or a stage 2 turbo cam or a stage 2 NA cam? If it's a stage 2 truck cam, you might not even need a converter. If you do, it's going to be something small, like a 2,500 or so. Rob, there might be some tuning issues there, like with one having back pressure and one not having back pressure. You might want to have less timing in the ones that have back pressure on them. So there might be some tuning issues there. Would you have the same heads with asymmetrical boost? Yes, that we did, and so does Saab, and different headers. You definitely have different headers because one of them has a turbo manifold feeding the turbo. The other one they have on theirs. I'm sure that they had some sort of cast or tubular exhaust manifold, not a long tube header like we were running. Scott, what did you tell me what size motor that you had? You want 450 foot-pounds, around 3,500. I'm hoping that you have a 6-liter there. That would be nice. Vehicular shenanigans. How much money have you made since you invented the Magic Eraser? I wish that was me. I know. I wish also that I was a guy on Pinks. The Parker funnel web is good, and you're going to run it boosted as a blow through. That's not going to be a really good intake with those cylinder heads in that camshaft. You should pick a dual plane. Yes, drum method. That's too high. It stalls at too high of a speed. You probably have a mild combination and too much converter in it, so it's going to allow the thing to slip until you. Or the other thing you could do is you could hit it with nitrous. Well, that's probably going to make things even worse. So yeah, you should tighten that thing up if it's a mild combination. Okay, the truck cam. Yeah, your 2,500 is probably fine. Scott, you're not going to make 450 foot-pounds on a 4.8. not there. Julius is in the house. Yeah, David Kraft, a 5,000 stall converter. That's for serious motors. Scott, a 4.8 with boost, you definitely can. Cuz 63. Years back, I had a Camaro with a 350 TPI. Yeah, tune port for the win. Now I have a Chevelle with a 383, even better, and it has a carb. Would like to put a tune port on that looks like the one that Chevy made on my 383. Any recommendations? The company, the first system, has something that should work better on that 383. Take a look at the video that I have up on the tune port intake test, where we tested what was, I think, all of the tune port setups available for Chevy for those tune port motors, and we tested it on a 383. Now, the 383 that we tested on had way too much camshaft because that's just what we had at the time. But it will give you a pretty good idea on what they'll do. A tune port on the 383 is going to be a really torquey motor. It works really good, but it needs to be a good one. If you put a stock one on it, you're really going to restrict it. Timmy Boyd, on a carb 6.0 with 823 heads on alcohol with 30 degrees timing straight across the board be too much. Yeah, I don't think I would want 30 degrees at 1,000 RPM at wide open throttle. But for the RPM range that we normally dyno test in, which is like 3,000 to 6,500 or something, you can do that. We normally put a curve in it, but we have run them also carbureted and run 30 degrees straight across, especially if you're running it on E85. Where are my 5-liter guys? Does anybody, especially somebody that has stock heads, does anybody need a set of bolt down 5-liter aluminum 1.6 roller rockers? If you do, send me an email. I have a set of those that I'm going to be listing here fairly quickly. Getting rid of those. I know that it's fairly specific, but they work good, I think. I even have a picture of one. Okay. Whoa! Yeah, full race rocker. Look at that. Yeah, yeah. All sexy. Yeah, yeah. Bolt down, little pedestal mount there. Wah, wah. So if you need a set of those have been only used a few times on the dyno. We ran, a bunch of testing with them and stuff. So if you need something like that, let me know. Andy, did you see the testing we did on the VVT stuff on the Gen 5? Those motors work really well. And honestly, I think that the answer for most of these guys wanting low speed torque, like everyone wants me to do the 6-liter, torque buildup, I think the answer to that is VVT. An LQ4, Scott, an LQ4 or an LQ9, either of those will work. Scott, I actually don't like the sloppy stage 2 in the 4.8 unless you're racing it and running high RPM. There's much better choices in that cam for a 4.8. How much power can an LQ4 make with just a cam? You can make over 500. Yeah, VVT is pretty prevalent now. Street Sweeper TV on deck is in the house. What's up? 2 7875s on 6-liter. Thinking of going with twin turbo cam BTR stage 3. Thoughts? We ran that on one of the Big Bang motors and it works fine. If you're running 2 7875s, you must be fairly serious about the kind of power you make, because that's 2,000 horsepower with a turbo. And if you're trying to do 13, 14, 1500 or whatever number you're trying to do, the stage 3 cam will work good. People delete the VVT because they're trying to put a performance cam in, and they're actually, for the Gen 4 stuff, there's not a lot of I think good VVT offerings. Although I never tested any of the stuff from Texas Speed, I'd actually like to see some of their stuff. But I would like to do more VVT cam testing. His problem is we could never run one, but we can run one over with Brian over at BTR. Well, if you're looking for the rockers, just send me an email. Yeah, James, the LQ4 or LQ9 has a little bit more compression. It's got the flat top in it. Evan, we don't know. I don't know what the advantage of asymmetrical boost is. I thought that they were trying to do it for fuel mileage, but I don't know that's the case. I don't know that they. I mean, the thing didn't last very long, so I was trying to ask other people if they knew of any situation where that might be beneficial. I just wanted to do it as a gee whiz thing. When building an extremely well-built short block, but running out of budget for heads, how much is too much cam for roller 90s 351? If you're using the stock heads, that's where you're limiting yourself. And you should have spent the money on the other side. You should have been using a junkyard short block and then put heads and cam and intake on it. You get much better results unless you're putting something together that you're actually going to race and you want to have really good parts in it. But the heads and the cam and intake are the things that make the power. The short block just survives that. And if you're going to be running, and then if you're going to run boost on it, it's a lot easier to make power. Yeah, Andy, the problem with the VVT stuff is finding the ECUs to run it. It's easy to put it on a Gen 3 or a Gen 4 motor. It's really easy to bolt on, but being able to control it and run it is a different thing. Could you explain sloppy stage 2 cam? It's just the sloppy stage 2 is just a designation given to that camshaft. It was from Matt over at Sloppy Mechanics, and it's the cam that his go-to camshaft that he said that you wanted for everything. And since everybody talks about stage 1 and stage 2 and stage 3 cams in everything, they just gave it that designation as a sloppy stage 2. And if you want to see what it does, I have a video up where we ran it naturally aspirated against a lot of other stage 2-ish cams. Paul, would a GT45 on an LS1 be a good combo for 550, 600 wheel horsepower with a Summit stage 3 or 4 cam? Yeah, you don't need that. You don't need a stage 4 cam to make that power. You can easily do that on a stage 3 or a stage 2 because the turbo is going to be the thing that's going to determine the power there. And the GT45 is about a 700 or 750 horsepower cam. It might be a little bit less than that on the LS1, but you can do that. Gen 3 and 4 doesn't have piston to valve clearance for VVT cams. Yeah, they do. they make Gen 4 VVT motors that have valve clearance in them. They don't have a lot. They don't have what the maybe some of the Gen 5 stuff does, but they have Gen 5 or Gen 4 VVT motors from the factory. The LY6 was like that. Brian's I don't even know what the designation is on that Gen 4 5.3 liter that they had, but it had valve reliefs in it because it was originally a variable cam motor. Yeah, Admiral, the Admiral saying there's plenty of cams that you can get to handle VVT. You just can't go too high of lift without running into possible piston to valve issues. The issue is not lift, it's actually duration. So it's not how far you open the valve, it's for how long you open the valve, and that gets even more critical when you're starting to open the valve earlier or later, depending on whether it's an intake or exhaust. And that's what VVT does. So VVT reduces piston to valve clearance because you're swinging it so far. But there's still room, I think, to have a performance cam that works well and works better than the factory stuff. Certainly, there's definitely upgrades to go from the factory stuff, but you can't go really far unless you have, you know, like Tim was saying, more piston to valve clearance. Lucky Do 79. I'm not sure you've made a video on this, but what's your opinion on Whipple superchargers? We've run lots of Whipple stuff. There's videos up on that on LS motors. I think I've only run Whipples on LS motors, though. I don't know that we've run them on. I may have run them on modular motors back in the day too. But we've run lots of positive. We've run Whipples and Kenny Bells and Magnusons, and so we've done lots of testing with those. Asymmetrical boost with cylinder deactivation. Maybe if you're trying to get good fuel mileage, I guess that would be good. Make it fit. Asymmetrical boost is running the turbo off of one side of your V8, or in this case, Saab did it with the V6. Josh, the GT40 heads are worth buying when you get them from the wrecking yard because they're really, really cheap from the wrecking yard. It's not the head that I would buy from Ford. I would buy a better aluminum head. Oh, boost, you want, Lucy, you want boost from selected cylinders. I don't know that that's going to work. The DoD stuff is going to be for fuel mileage, not for power. Java, thank you for hitting that like button. 4 a.m., man, you can't be staying up that late. Yeah, the Coyotes do VVT also. A TVS style blower is just a roots blower. It's a modified roots, but it's a roots blower. Get all the exhaust to the turbine, otherwise you're wasting heat energy. Yep. So Mike and Evan, explain to me how DoD is going to make that situation better, other than having get better fuel mileage. Why would you want to eliminate cylinders? I don't understand how that's going to work. Yeah, I agree. They do. Holly does need to have VVT control. That would be nice. 2019 5.3 is an L83. So I just did a couple of videos on that. You can take a look and see what they're good for. Armchair Mechanics has a compound setup that works good. So Evan, you're changing the compression now on one side and the timing, but that's not DoD though. Plus cylinder deactivation. That's what I'm saying is the cylinder deactivation is going to improve fuel economy, but it's not going to benefit the turbo part of it. Arduino VVT controller. I've never tried one of those. Scott, most people do buy, his question is for reliability, would be best to buy a turbo with 100 horsepower over what you're planning on running. I would say that that's kind of the minimum. A lot of guys do more than that because they're eventually going to go more than that. But if you want the most response, then sizing the turbo for your power needs works out best that way. But yeah, leave yourself some room, and 100 horsepower is a good amount. Nick is saying, my friend just got done with an L99 with a stage 3 GPI VVT cam, and it works great. There are VVT stuff. There's definitely VVT stuff out there for the Gen 3 and Gen 4 stuff. Well, Todd wants to know what he's got one or two 6V53 blowers, and he wants to know what to use them on. Do you have another engine that you want to put them on? John, cam phasing is the same as VVT, and your 3 valve, if it came in a Mustang, has variable cam. Armchair, my question is, why are you going to all of that trouble? What motor is this on, and why wouldn't you just run the GT45? Hi boy, I don't know. You could get stuff from Summit or BTR. That those are all the normal places. Admiral, I don't know what you're talking about. The difference between VCT and VVT. They're advancing and retarding the camshaft, but they're not VTEC, if that's what you mean. VTEC and VVT are dramatically different. What's a good ring gap for boost on a 6.0? That would be 28 to 30 thousandths on both the first and the second ring. Yeah, make sure to check if it came out of a fire, you got to check all of your stuff. With the 3000 GT stealth stuff, upgrading just one of the turbos, what sort of impact would it have on longevity? I don't think it'd have effect on longevity of the engine so much as the longevity on one of the turbos. Yeah, Noodles, that's a good point. The people that are wanting fuel mileage out of a turbo motor, you just need to not be on the gas so much. But nobody wants to do that, though. Yeah, Julius, that might work. You have a velocity stack from a 4150 with the K&N filter. Would that work? Yeah, as long as you can clamp it onto that stack. Yes, VTAC, that's the way to go. That's much better than VVT. Although having VTAC and VVT is definitely a really good thing. Best low-end torque heads for my 4.8 liter. They're the ones that you have on your 4.8 liter. A 706 or an 862. Or if you want to put an aftermarket head on or a ported version of those heads is also really good. But the 205 trick flow head, it works really good. I have used gapless rings, but not on any of the boosted motors. You have a turbo deactivation on your LS. It's just always deactivated. Yeah, the 4200 will be the first one with VVT tuning. Although when I was back with Brian, they were obviously tuning the L83 and the L86 and the LT1 stuff that had VVT on it also. I still have the 5.7 Hemi that I boosted. I'm putting Edelbrock heads and intake on it next. Armchair, I'm with you, man. Try unconventional stuff. Jacob, I don't think I have any more 462 valve stuff. Tim, is that question for me? How do you sweep VVT? We sweep it this like we did on the Honda on the K24. We just started at 0 and we went up to 25 or 30 and found out where it wanted to be. It has enough piston to valve to do that, but that's one of the things you got to make sure that you do. I have a Richard. Do you have any project cars of your own? I have a Nova, 72 Nova. I have a 71 240Z, and I have a 1988 5-liter Mustang and a 5-liter LX. Craig, I have not reached out to Lawrence Tolman about getting his 8.1. GT3540. I've never heard of a GT3540. Cameron 30 is fine for that. No, not a 240SX, a 240Z 71. Not that there's anything wrong with the 240. Those are cool too. Lots of drift guys obviously like those things. And they already have an R200 rear end in them, which is nice, which I wish the early Z had. MB, there's still lots of the GT40 cylinder heads in the junkyard, and the regular ones and the P heads. Craig, I'll send him your way. That's LT from Power Nation. Okay, cool. They do some good stuff over there. So, Mark, do we need to try that after we go through the tuning sequence with the isn't the exhaust cam the only thing that has VVT on that 4200? I think it is, right? So we're only going to be adjusting that. So you want to adjust that mechanically first? Michael wants to see a Turbo Ford FE. My buddy had a freshened 5.3 with a Turbonetics Bonita dyno tuned. It only made 560 wheel horsepower at 18 pounds. So 664. What's the problem? If the 5.3 has a cam in it, it should make more than that. And I don't know what the tune, maybe he's only running, maybe that's pump gas and he's only running, 10 or 12 degrees of timing on it. If that's the case, then that's understandable. If he's got good gas in it, it has a cam in it, it should make more power than that. Live from the wrecking yard. I need to go down there. I do want to go to the wrecking yard when I go down. A Turbo FE, yeah, that would be cool. Big Bang 455. I have the 455 going together, but I'm not gonna blow it up though. I've run lots of testing with water meth, Cameron. Palmer, I'd like to run the 5-cylinder and the 4-cylinder Atlas motors too after we do the 4200. I don't know that we will because I don't know what the difference is going to be, but it would be cool. I like the old Celicas. What I like even more than that is the my buddy has an early Corolla, which I like even more. Okay, you're talking about, Mark, when we put a different cam in it that we need to advance it. And then we can put stops in the VVT mechanism, right? So we can stop it from, we can change the amount that it can sweep. Would it be silly to twin turbo basically a stock L19 big block? You're in the wrong place if you're asking that question. Come on, man. Take a look at the video that I have up on the Boneyard Boost. We did exactly that. It works good. John, I don't know anything about the 2.7 liter 4-cylinder Cadillac version, unless that's a variation of that Atlas motor. 3S GTE is an underrated motor. Yes, Palmer, I do want to do something with the V10. Tim wants to see a serious build on a 2.7 liter. Okay, that's what I was thinking, Mark, that we could limit that. Excuse me, Jacob, what do you think of Toyota engines that run 14-to-1 compression on 87 octane? Well, they'd have to do that with not very much timing. Or is it a direct injection motor? Or is it a diesel? Yeah, Joseph, that was done long ago with V8s. Has anybody made a mechanical VVT with weights like a distributor? Yeah, they did that on the cam gear. I don't know how well it worked though. I've never actually seen it tested. Yeah, early 70s Celicas are cool. Armchair, I don't know what you're talking about. What do you think a back pressure difference between banks would do to tubing and performance? I don't know what you mean by tubing and performance. How many pounds of boost can a stock 351 Cleveland bottom end 2V rods, ARP bolts handle? A lot. If it's, I've never tried to run a boost of Cleveland so that for all that it's worth, so I can't really say an exact number. I would, given what we've done with Windsors and Chevys, I would say it's probably a lot more than people think. Oh, Joey, so the 3540 actually is a number from the Falcon cars. Okay, that's cool. Okay, Jacob, it's a DI motor. That makes sense then. Palmer, I don't know what the limit would be. I mean, we've run high 11 stuff on 91, so you can certainly get away with a lot more with E85 on an NA motor. Rhodes lifters are actually not VVT because they're not changing the cam rotation. They are changing. I think that what they're changing is lift, though, right? Yeah, James, those 22 Rs with turbos on them, you got to watch out for those. JVV, we have tried different injection timing on LS motors and not found a whole bunch by doing that. Palmer, I got into it because of, I think, because I'm a guy. My first car was a 70.5 split bumper Camaro, and started reading magazines before that. Started reading Hot Rod and Carcraft and all those things kind of before that. My stepdad took me to a couple of car shows, like I think it was one of them, the big Roadster show in Oakland, I think, and it was very, very cool. I thought that all that stuff was great. How does a Rhodes lifter lose on the closing ramp? And it's still not, that's still not rotating the cam, right? It's still not changing the cam timing. It's not advancing or retarding the camshaft. Craig wants to swap a Dodge Dart with a 4200 and make the new new gen Super 6. That would be good. It definitely would be a lot more super than the other one. When running an asymmetrical combination, would the orientation of the pipes going into the collector make a difference? When Saab was doing it, I think that they just had a stock style exhaust manifold feeding the turbo. I think that theirs was typical of what an OEM would be, so that they weren't orienting the pipes in any way. I think it was a log style manifold. Jonathan, the multi-spark is beneficial for low speed stuff because it only does it up to 3,000 RPM, like the MSD stuff. The ignition amplifier can be beneficial on like boosted applications when you have the spark not wanting to make the jump when it's lazy. But that's when an ignition amplifier, the multi-spark stuff is really for drivability. On topic, where the Trans Am turbo engines run off one bank? No, they were just like the Grand National. They fed the whole exhaust to that. How is the 225 coming along? Which 225? Are you talking about the Dart? Linwood, we were just talking about asymmetrical turbos in general. I haven't tried it on an LS. I tried it on a big block though. Brazil's in the house. Michael, I don't have any way to put the Toyota V8s up on the dyno right now. I thought the loss in lift was based on, I thought it's based on oil pressure. And so it's it's biased with RPM, I thought, because the oil pressure goes up with RPM. Although if you don't have a rising oil pressure curve, then that wouldn't be the case. Reb Auto wants me to do a big bang on a small block Ford. That would be easy. I would do it on probably an Explorer motor. The Dodge Dart, Mark, is I think the head is fixed on it, so we just need to put it back together. Yeah, James, the guys at Goat Rope Garage on YouTube, they do a good job. He does a lot of tuning stuff. So if you have tuning questions about tuning, especially HP tuners and factory stuff, he's a good guy to watch. Are you planning to test direct injection engine with port injection? Do you think you'll gain horsepower? Oh, we are going to do that. I'm going to do that back with Brian on the L83. We'll run it port injected and direct injected and see what happens. I don't have a video on the asymmetrical because it didn't do anything. We could never get it to make boost, so I never did a video on it. Yes, the Skid Factory stuff is good. I've seen that stuff, Julie. So that's cool to bear. So I got about 2 more minutes, and I got to get going. Get those likes going, yo. 169 versus 116. Man, those are rookie numbers. Come on, guys. I do like the Goat Rope guys. I like Kyle over there. As a matter of fact, that reminds me. Thanks for reminding me. I need to give him a call and ask him some questions about some stuff. Richard, did you ever watch Project Binky? Refresh my memory of what that is. Palmer, what do you think about doing anti-lag testing? Anti-lag testing is probably not a good idea on the engine dyno. No, Julius, I still count the one dislike. I would sure like to find out who that is. Oh, the all-wheel drive Mini, cool. All right, guys, I have to get going. Thank you all for showing up. Good times, good times. Hopefully I can get down and figure some stuff out on the 4200. Yay! I'll see you guys.